Hello guys, in this video we are going to discuss the solution of the problem check for children some property in a binary tree. So let us look at the problem statement. The problem statement says that we are given a binary tree with n nodes. Check whether all of its nodes have the value equal to the sum of their child nodes. Return true or 1 if all nodes in the tree satisfy the given properties, else return 0. For every node, data value must be equal to the sum of the data value in left and right children. Consider data value as 0 for null child. Also, leaves are considered to follow the property. Okay. So if you see this example, this is the binary tree given to us. 35 is equals to 20 plus 15. So this node holds the property. 20 is equals to 15 plus 5. This node holds the property. 15 is equals to 10 plus 5. This node also holds the property. And as per our question, leaf nodes hold the properties. So since all nodes hold the property which is defined in the question, thereby we are going to return 1 for this particular example. Let us look at the second example. In the second example, if you see, the root is 1, whereas the left and right is 4 and 3. So 4 plus 3 is 7, which is not equals to 1. So thereby we are going to return 0 in this particular case. So that's about the problem statement, folks. Now let us look at the solution for this problem. So the solution is pretty simple. So the solution is, in order to understand the solution of the problem, let us look at various types of trees which we could have. So case 1 will have a tree and this is an empty tree. Okay. In case 2, we could have a tree something of this sort. In case 3, it might be possible that only left child of the node exists. Case 4 could be the right child of the node exist. So these are the 4 cases which we have, and once we solve these cases, we will be able to complete our function. So let us see what we can do is in the first case. So for case 1, if the tree is empty, right, then we are going to return true. So the first case would be if the tree is empty, or after iteration we have exhausted all the elements, then we are going to simply return true in this case, or return 1. In case 2, which is the case where we have left and right child both, so we are going to check if root left and root right exist. If both the children exist, then we are going to check if root dot left dot data plus root right dot data, this summation is not equals to root dot data. If this is not the case, then the property is not satisfied and we should return 0. So we are going to return 0 in this case. Otherwise, we are going to check our case 3 and case 4, right? So case 3, only one node exists, or let's say this if root dot left only exists, then in that particular case we are going to check if root dot data is not equals to root dot left dot data. If they are not equal, so case 3 is the case where only the left child exists, so then this data or the roots data, this should be equals to the left child data. If that is not the case, then the property is not satisfied and we are going to return 0. Let me just. Otherwise, the case 4 we will be there. We will get into case 4, and the case 4 would be, which is the right exists only the right exists. So we are going to say if root dot data is not equals to root dot right dot data. If they are not equals, then we are going to return 0 in that case. Okay, so these are the 4 cases, and let's handle the leaf node cases as well. So let me represent case 5 for leaf node. So leaf nodes are those nodes uh, whose left and right child are null. So let me just write it down here. So this should come between C1 and C2. So case 5 will be here, which is if it's a leaf node. So leaf node, let us check if it is a leaf node. So if it is a leaf node, then the left is none and right is none, right? Root dot right equals to none. So if both are none, then we are going to return 1 because a leaf node holds the property. So these are the 5 cases which we are going to write. And once we have integrated these 5 cases, our problem will be solved. So let us now write down the algorithm for this. So let's write down the algorithm. So so let's say this is the function which does the job, and we have root given to this function. So the first thing which we are going to check is our case 1. If not root or the tree is empty, in that case we are going to return 1. Here we are going to check our leaf node case. If it is a leaf node, which is root dot left equals to none, and root dot right equals to none. If it is a leaf node, then we are going to return 1. Otherwise, the cases we have talked about, which is we will begin with if the left and right child exist, if root dot left and root dot right, so both left and right child exist. In such cases, the sum of left and right should be equals to the root data. So root dot data, if it is not equals to the sum of let's just write down equals here, root dot left dot data plus root dot right dot data. So if they are not equal, then the condition or the property is not satisfied and we are going to return 0. Otherwise, we will check if only the left tree exists. So let us check that. Elif root dot left, just a second, dot left, then we are again going to check if root dot left dot data is not equals to root dot data, then return 0. Else only the right child exists, and let us compare the right child as well. So if root dot right dot data is not equals to root dot data, then return 0. Let's just scroll down. Otherwise, and let us say, and now so root has been we have determined what should be the value of root, or whether we should proceed forward or not. We have already determined. Now let us look at the left and right subtree. So left subtree is equals to the function itself, and let us recurse on the left side and right side also. So let's check the values on the left and right side of the tree. Okay. Now if both left and right side satisfy the condition, if left and right satisfy the condition, so they both will be true in that case, then we are going to return 1. Otherwise, we are going to return 0. Okay. So that's about the explanation, folks. Now let us look at the code and see how the code looks like. So I have already coded it, and it is the same as what we have discussed here. So this is the first case where the tree is empty. In that case, we are returning 1. If it is a leaf node, then we should return 1. Otherwise, if left and right child exist, then the summation should not be, if the summation is not equals to root data, then it is 0. We need to return 0. If only left child exists and it is not equals to root data, then we will return 0. If otherwise right child exists and if it is not equals to root data, then we are going to return 0. Otherwise, we are going to check left and right. And if both left and right holds the property, we are going to return 1. Otherwise, we are going to return 0. So that's about the code, folks. Now let us submit our solution. So our solution got accepted. So that's from this video, folks. If you have any question or queries regarding this video, please feel free to use the comment section and I will try to address them. Thank you.